Hello dear students, let us discuss on the topic food containers. Today, the role of packaging is uppermost in contributing to higher sales of food products. All products are looking forward to new and more appealing packages on the one hand and more economical and high-performance packaging machines on the other. Tin and glass containers have so far been successfully employed for packaging foods. Eppert made use of glass jars or bottles, while Peter Durant employed metal containers. A great deal of development has since taken place in the manufacture of both types of containers. Both tin and glass containers are employed in the canning industry, although the tin containers are more common in use. In recent years, plastic containers and heat-sealable pouches are being used for the familiar tin and glass containers. Now, let us discuss about tin containers. Tin containers are fabricated readily and are strong enough to withstand processing. They are light in weight, easy to handle, and fairly cheap. Tin cans are made of thin steel plate of low carbon content, lightly coated on either side with tin metals to a thickness of about 0.0002 to 5 cm. Base steel plate. Since corrosion behavior, strength, and durability of the tin plate depend in some measure on the chemical composition of the steel base, the base plate is made according to the specific use for which it is intended. The active elements present in the base plate are principally copper and phosphorus. The more of these elements present, the greater the corrosiveness of the steel. However, more is the phosphorus present, stiffer is the plate, which is desirable for certain applications such as the beer can, where high pressure are developed. Types of plating. Cans are made from sheets of steel that are tin plated, then enameled and leveled. There are several types of plating. Number 1. Electrolytic plating. This is the most common method of plating. Tin is the anode, the steel base plate is the cathode. Both are suspended in a concentrated solution of a tin salt and tin is deposited with large electric currents on the steel base plate by ion transfer. Then number 2. Differential plating. In this process, more tin is deposited on one side of the base plate than on the other. The heavier surface is used on the interior of the can. Then number 3. Hot dipped. In this, sheets of steel base plate are dipped into vats of molten tin as often as necessary to produce the desired thickness of tin coating. Lacquering. It is difficult to coat steel plate uniformly with tin during the process of manufacture. Small microscopic spaces are always left uncoated, although the tin coating may appear perfect to the eye. Contents of the can may react with these exposed parts and cause discoloration of the product or corrosion of the tin plate. When corrosion is severe, the steel is attacked and black stains of iron sulfides are produced. It is necessary, therefore, to coat the inside of the can with some material like lacquer, which would prevent discoloration, but would not impart its own flavor or injure the wholesomeness of the content. This is achieved by lacquering the tin plate. There are two types of lacquers. They are acid resistant and sulfur resistant. The acid resistant lacquer is ordinary gold colored enamel, and the canes treated with it are called R-enamel canes. These canes are used for packing fruits of acid group with soluble coloring matter. Acid fruits are of two kinds. Number A, those in which the coloring matter is insoluble in water. Number B, those in which it is water soluble. In the first group, fruits like peach, pineapple, apricot, grapefruit, etc. are included, and in the second, fruits like raspberry, strawberry, red plum, and colored grapes are included. Fruits of Group A are packed in plain cans and those of Group B in lacquered cans. The sulfur-resistant lacquer also is of golden color, and the canes coated with it are called C-enamel canes or SR canes. These canes are used for non-acid products like peas, corn, lima beans, red kidney beans, etc. to prevent discoloration of the contents and staining of the inside of the container. They are meant for non-acid foods only and should not be used for any highly acid products. Coating. To further protect the products and adverse product reaction to the cans, coatings are also applied to the outside of the cane. Coatings are the non-toxic external paints or enamels that are applied for the purpose of preventing corrosion and providing camouflage. The coatings are pre-coated or post-coated. Pre-coated coating refers to a coating applied to the exterior flat sheets of tin plate prior to fabricating the tin plate into canes. Post-coated coating is applied to the exterior of food cans after they have been filled with food, sealed, and processed. Steps in can fabrication. The tin has been applied to the steel base plate during the plating process to make what is known as the tin plate. Step A. Initial sizing and cutting. The first step is the slitting of the tin plate into body shanks, which yields can bodies with the desired dimensions, and the notching and beveling of the body blank. Notching and beveling reduces the layers of metal incorporated in the can ends. Step B. Preparing the edges. The next step is the bending and hooking of the notch and bevel sides. The knots and bevel sides are bent directions to form hooks. Step C. Shaping the cane. Next, the body is formed around a steel mandrel of the desired shape and the hooks are interlocked. Step D. Preparing the side seam. During the next step, called bumping, the hooked areas are hammered together to form the side seam. This bumping is followed by flushing and soldering. Flushing is done to remove any oil or excess enamel or other impurity from this area. In the soldering operations, hot solder is allowed to run into the seam to coat all the tin plate area therein. Step in attaching the end of the cane. The next step is the application of the end of the cane to the body and includes flashing of the body. During this step, the outer edges of the cylinder formed around the mandrel are turned outward toward a 90-degree angle. The end is formed to fit over and around this flange by being pressed out of tin plates. The portion of the end that fits around the flash is called the cover curl. This curl is filled with rubber-based gasket compound that will form a hermetic seal when the cover curl is bent around the flange. Step F. Preparing the double seam. This formation is performed by two rollers which revolve around the can, pushing the flange downward and compressing the cover curl completely around the flange. The first operational roll lightly rolls the cover curl and the flange together, and the second operational roll tightly presses the two together to form a hermetic seal and the double seam. Beading. Beading is a method of strengthening a cane by reinforcing ribs or concentric depressions around the body. Beading increases the resistance to paneling. Cane styles. The cane style varies with the product it is to hold. Cane styles have been given names according to the characteristics of the cane. The first is extruded or drawn. Canes that are round, oval, or oblong in cross-section are extruded canes. Some items packed in extruded canes are sardines, herrings, jellies, desserts, and military rations. Square, rectangular, or oval canes. Some canes are square or rectangular in cross-section and have double seam or soldered on ends. These canes are commonly used for luncheon, meats, hams, loaf-type items, and survival packets. Hole and cap or vent fillers. These canes are square, round, or rectangular in cross-section. They have double seam or soldered on ends and are used to package evaporated milk and anhydrous milk fat. Then, beaded cans. These have intended grooves around the circumference of the cane body that are parallel with the double seam. It is used mainly on larger cans that tend to have weaker bodies. Can labeling methods. Can labeling serves to identify the content of the can as to contents, weight, manufacturer, and processing plant. The labeling used on containers depends on the product and its intended use. The first is lithographing. Lithographing is printing which has been baked to the surface of the tin by heat treatment. Number B. Stamping. Stamping is the application of marking with an ink stamp. It is not bonded to the surface of the tin with heat, although it may be subjected to heat in order to speed drying. Then next is embossing. In embossing, the markings are raised in the tin plate of the can end or of the body. These markings must not be sharp or have well-defined edges. Paper labels. Paper labels are permitted for domestic shipment on military contracts. They are rarely used on products that are shipped overseas because the glue tends to hold moisture in close contact with the can, resulting in corrosion. Size of cans. According to American system, which is widely followed in trade, cans are usually referred to by a letter and number, and the size is denoted by a digital symbol. The first number of the symbol denotes the diameter and the second the height of the cane. The first digit represents integral inches and the last two indicates measurement in sixteenths of an inch. Thus, A2 half canes, which is 4 1/16 inch diameter and 4 11/16 inch height would be shown as 401 by 411. The latest trend is to mention the diameter and height of the can in millimeter. Glass containers. Modern technology permits the production of glass that is competitive with other container materials in function and strength. Components of a glass food container are the body, the bottom, and the closure. The glass containers are fragile and require extra care in handling during processing. They, however, possesses two definite advantages over tin cans. The contents, being visible, can be easily displayed, and the containers can be used over and over again. Further, since glass of high quality does not contaminate the contents, glass containers are preferred for packing baby foods. The tray pack. Characteristic of tray pack. The tray pack cans, also called the half-size steam table tray, is a low-profile, two-piece, retortable, institutional-size container. It is extruded from chrome steel plate and layers of chromium oxide, and a base of epoxy. It is enameled with modified vinyl inside and out. The dimensions are 7 by 8 inches by 12, 1 by 4 inches into 2 inches. The capacity is of about 105 ounces of food. Due to its low profile, retort process times for the tray pack may be reduced as much as 60%. Retort pouches. Characteristics of retort pouches. The retort pouch is a flexible, heat-sealable container that is thermally processed like a can and may be used to produce shelf-stable, commercially sterile food products. It is constructed to a 3-ply laminate composed of an outer layer of polyester film, a middle layer of aluminum foil, and an inner layer of polypropylene. The layers are bonded together with an epoxy adhesive. The polyamide material provides seal integrity, toughness, puncture resistance, and superior barrier properties for long shelf life. It also withstands the rigors of thermal processing up to 275 degrees Fahrenheit, that is 135 degrees Celsius. Conclusion. Containers are a convenient and attractive means of packaging products. They also protect food from environmental influences and damages during distribution. With the general use of packaging and the development of modern techniques of food safety and commercialization, the universalized consumption of all foods has become possible without distance or seasonal limitations and at an adequate cost. Efficient packaging is necessary for the commercialization of every food type, from fresh produce to ready-to-eat meals. Nowadays, a wide and diversified supply of packaging materials and designs are available to suit the specific requirements of industry and consumer. Rigid and semi-rigid containers made of a wide variety of materials are used for packaging a wide range of products. Packaging industry has to gear itself to the modern and updated food and agricultural industry in a dynamic way.